All right, my friends, and so we are back at it again. All right, so going to continue our conversation about exponential. So hopefully, you went through the exploration. That was kind of like our opener for today. All right, you saw a few things, you got to think about a few things, and now our hope is to show you how to put all those things together, refresh your memory about some things you probably know but haven't thought about with exponentials in a little while. So let's look at our notes here. So at the top here, we've listed just a few things, right? And so let's start with our equation here, right? So we've got a few parts to our equation, right? So we have A, which is we think about that as the initial value of our problem, right? Or our multiplier in regards to what's going to happen to the values in our range. So B is the base of our exponential. And now, once again, we're going to see x minus h and we're going to see k. So just to review a few things, right? So when that base is greater than 1, we know that we will have an increasing graph. So it's going to be going uphill from left to right. When b is between 0 or 1, it's going to be decreasing. It's going to be going downhill from left to right. Okay, so k is our vertical shift. And like we saw in the opener, in the little exploration, that's also going to tell us about our horizontal asymptote. H, just like with all of our other functions that we've discussed this year, is our horizontal shift. All right, and then A is that initial value, and we talked about that. All right, and we'll use that relationship that we know that our y-intercept, if we're on the y-axis, or our first point is going to be A units above our horizontal asymptote. Okay, so now we're also going to just talk a little domain and range as we go through these. All right, so all right, what I'm going to do is really just for every problem, I'm going to look at my base and I'm just going to create, all right, a very quick table of values. And we really just need 3 points, all right, as we do this. If you want to generate more, you're always welcome to, all right. But really what I'm going to do is when I think about my XY table, I'm really just going to take -1, 0, and 1 and use those as my key points. All right, and I'm going to think about my base. So I have 2, right? So if I think about 2 to the x, right? And I'm not going to perform anything on this. I'm just going to think about the base as itself. So 2 to the -1 power is 1/2. 2 to the 0 power is 1. And then 2 to the first power is 2. So these are the 3 key points that I'm going to graph every time I graph 2 to the x. Now, we're going to talk about this in regards to graphing, that we're always going to find that new origin that we've talked about by doing our vertical shift and our horizontal shift to find that new origin. All right, and then I'm going to apply this A value, all right, to my domain, or excuse me, to my range values once we've done that, okay? So let me show you how this works. All right, so the first thing I want to do is find my vertical shift. So we see that -7. So what I know, all right, I'm going to do this a little bit fancier since I can, all right, is that, all right, we're going to have a horizontal asymptote at -7. So if I go down 1, 2, 3, 4, 5, 6, 7. All right, so you can see, we know, maybe, let me go backwards. All right, being a little unruly here. No, it's all over the place. Oh, don't you hate it when technology is like, I don't know what's going on here. It's just doing whatever it wants to do at the moment. I was trying to be fancy. It's just, I'm not even touching anything right now. I'm just sitting and watching like you guys. All right, wondering when it would just stop. All right, so let me try this one more time. So 1, 2, 3, 4, 5, 6. All right, so we're going to have our horizontal asymptote at -7. Let me see if it'll just go here. Oh, nope, it's going to, oh, it did actually stop. All right, so let me see if I can straighten her up here. No, don't want to move that. I want to move this guy. Maybe. Oh, we have victory. Oh, got to be just persistent and go, right? All right, so there's our horizontal asymptote, all of that just for a vertical shift, right? So now, all right, now we're going to look for a horizontal shift. And no, there's no h value, so we're not shifting right or left. So what we know is that this point right here is our new origin. And now, if we did not have any a value, if this a value was 1, what we would know is from that new origin, I would move to the left and I would go up 1/2. So I'm still going to move to the left 1. But because of this, this only affects our range. It only affects those y values. So instead of going up 1/2, I'm still going to go to the left, but I'm going to go up 3 times 1/2, which would be about 3/2. So that's going to be kind of right in here. All right. Now, I also know that if there was not an a value, or the a value is 1, I should say, I would only go up 1 from my new origin, so up 1, right? But my a value is 3, so instead of going up 1, I'm going to go up 1, 2, and 3, like that. Now, once again, this gets into that opener that we just talked about. You can see that that point is a units above a horizontal asymptote. And then I would go to the right one, and I would go up 2. So right 1 up 2, but now because of the a value, instead of going up 2, I'm now going to go up 6. So 1, 2, 3, 4, 5, and then 6 would be right here. And now let's see if I can draw a curve through those points. All right, so something like that. All right, and there's our somewhat funky looking graph of an exponential. All right, so now, all right, let's look at, all right, number 2 here. Now, what I wanted to do is show you the process with this, because that looks really similar to what we did in that warm-up and that exploration. And now I want to show you the only thing that changes when we have a horizontal shift in addition to our vertical shift as well. So what I'm going to do is try to do this again, but I think what I'm going to do is just pause the video, and I'm going to put the horizontal shift and the vertical shift in. That way, if it's giving me any issues, it doesn't force you to sit there and watch me work through them. So hold on just 1 second. I'm going to do a little movie magic. And looky there. All right. Whew, there we go. So now, notice we still have the same k value. So we still have that horizontal asymptote at -7. But now notice this is x plus 3. And what we know is that this negative is part of the formula. So if it's x plus 3, what that is really telling me is that I have a horizontal shift, all right, up to the left 3. So 1, 2, 3. And that's why I have this, all right, as a dotted line. That's my new vertical axis. So what I know is this point right here is my new origin. So I'm going to apply the same points, but I'm going to count from that new origin. So I would still go to the left one and up 1/2. But now, once again, I have this 3 out front. So instead of going up 1/2, I'm going to go up 3/2, which would put me right in the middle there. And instead of going up 1 from that origin, because of this 3, I'm going to go up 3. So 1, 2, and 3 right there. And then instead of going up 2, right, when I go to the right one, I'm now going to go up 6. So to the right one, and up 1, 2, 3, 4, 5, and 6, like this. All right, so, and there we go. All right, that's a better looking graph. All right, so that's the process. All right, so let's go down and do a couple more together. All right, and then once again, I'm just going to try to illustrate how you should think about this in addition to the points and your shifts and such. So once again, I see that my base is 1/3. So I'm going to come over here just real quick. All right, and I'm going to create, all right, an XY table. All right, and once again, I'm just thinking about 1/3 to the x, right? So this is all I care about. I just want to know what are 3 good points. And once again, I'm still going to just take -1, 0, and 1 here, right? And I know anything to the 0 power is 1. Anything to the 1, or to the 1 power, to the first power, is itself. And then the -1 power is the reciprocal power, so that means that's going to be 3, right? So there are my 3 key points that I'm going to work with. So now when I look at number 3, I'm going to look for my horizontal shift, or my vertical shift first. And notice there is no k out here. It's +0. So I know I'm still going to be on the x-axis here. But I do have a, or excuse me, did I say vertical shift? My vertical shift is 0, so I'm going to be at the x-axis still. Now my horizontal shift is going to be to the right 5. All right, once again, I'm going to pause real quick. I'm going to put in that horizontal vertical dotted line. You might want to do the same while you're waiting on me. All right, so what I did was just, once again, we have our vertical shift is 0, so I went ahead and put that horizontal asymptote at 0. We can see that our vertical shift is at 0, excuse me, and our horizontal shift is at 5, so I put that in. So now, so 5, 0 is our new origin. So once again, when I look at this, I would normally go to the left one and up 3, but I have this 4 out front. All right, so I'm still going to go to the left one because the 4 does not affect domain, it only affects range. But instead of going up 3, I now have to go up 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And we'll just estimate that 12 is somewhere right in here, right? So somewhere in that general vicinity. All right, now I would normally just go up 1, right? Stay at the origin, go up 1, but because there's 4, I'm going to go up 4. So up 1, 2, 3, and there is 4 right in here. All right. And normally I'd go to the right one and up 1/3. So I'm still going to go to the right one, but instead of going up 1/3, I'm going to go up 4/3. So I'm going to be just a little bit above 1 there. And once again, notice our base is less than 1, so we're going to have a decreasing function. So that's why it's going downhill from right to left. And there it is. All right, so now once again, just to illustrate how it all works with both a horizontal and a vertical shift. So what I want you to do is pause the video. I want you to draw in your horizontal and vertical shift while I do the same, and then we'll see if we match. All right, so did you get a horizontal shift up to the right 5? All right, did you get a vertical shift of down 9? So you can see that the point 5, -9 is now our new origin. So once again, we still have this a value of 4. I'm going to go to my normal table here, right? And so once again, to the left one up 3. So I'm going to go to the left one, but instead of going up 3, I have to multiply that by 4. So I'm going to have to go up 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12 would be right in there. All right, and then now I normally would just go up 1 from the origin, but I have to go up 4 because that multiplier. So up 1, 2, 3, 4. And then I normally would go up to the right one up 1/3, but now I'm going to go up 4/3, so somewhere in there. And once again, our base is less than 1. And we're going to have a decreasing function. Oh my goodness, that was just really bad. So let's undo that, see if I can manage to hit the points at least in a vague sort of way. All right, so obviously it does not go below that line there, but you can see that. All right, so let's look at number 5. All right, so I'm going to do one more with you, and then I'm going to set you to do the last 3. Now, if you feel comfortable, you can go ahead and pause the video and do all 4 of these together. But I'm going to do one more with you before I set you off. And once again, what I want you to do is I'm going to put in my horizontal vertical shift, and I would like you to do the same, and then we'll see if those match. All right, so I have a vertical shift of up 1, so I have a horizontal asymptote at 1 here. All right, and then now I have my horizontal shift to the left 3, so to the left 3. So there we go, so 1, 2, 3. Now, once again, notice my base is 1/2. All right, so what I want here, create a nice little table here. All right, so X, Y, and once again, we're just going to do the -1, the 0, and the 1 here, and we said our base is just going to be 1/2, all right, to the x here. So we know 1/2 to the 0 power is 1. We know 1/2 to the first power is 1/2, and we know -1 is the reciprocal power, so that'd be 2. All right, so now this is our new origin right here, -3, 1. So normally I'd go to the left one, and I would go up 2, all right, but now I have this multiplier here, so I have to go up 10 instead of 2. I'm still going to go to the left one and then up 1, 2, 3, 4, 5, 6, 7, 8, 9. And then 10 is just a little bit off of our graph there. And then normally I would be just 1 above my horizontal asymptote, but I have a 5 here. So I'm going to go up 1, 2, 3, 4, and 5 right there. And normally I go to the right one and up 1/2. And then now I'm going to multiply that 1/2 by 5. That's 5.5 or 2.5. Or 5/2, excuse me, or 2.5. So to the right one, up 1, 2, and then 2.5 is right in here. And then once again, our base is less than 1. Therefore, we're going to have a decreasing function. Oh man, that looks like a quadratic. Oh, my tablet is really struggling to keep up real quick here. Try it again. Oh my goodness. This is really, really bad. Really bad, really bad. And poof, there it is. Whew, man, I didn't know if I was ever going to get it. All right, and that's really how we graph everything. Now, here's one thing that we haven't done, and I wanted to go through the graphs real quick with you, and now I'm going to circle back to the other piece of the puzzle that it asks us to do. So I'm going to go back to 1 here because it also asks us to talk about the domain and the range, all right, of all of our graphs. Now, here's what we should hope and you should remember is that when we think about domain, right, we can always raise everything to a power. So there's no issues on the domain. So our domain for all of our exponentials, right, is always going to be all real numbers. So we don't have to really worry too much about that. That's always going to be the domain, right? So we can raise any number, all right, okay, any base we have, all right, to any number. So we know the domain for everything is going to be all real numbers. So that makes it a little bit easier for us to work with, right? Now, what we know is when we look at each graph, the range is the y values. And what is going to help us with that is our vertical shift. So notice for this, -7 is the lowest value we have, right? And it gets really close to -7, but never touches, and then goes up forever. So when we think about our range, all right, for the first two functions here, for 1 and 2, both of these are going to be -7 to infinity. And then once again, we're going to have an open bracket here because we never quite get to -7. We get close, but we never quite, all right, touch it. So same thing here, -7 to infinity, right? And we look at our last two graphs here on 3 and 4. So when I look at the range for this one, all right, when I look for the range here, my horizontal asymptote is at 0. All right, so I can see that it's going to go up and get all those values. And so once again, my range would be 0 to infinity. And that 0 is going to be an open interval, right? We never quite get there. Now, notice on number 4, our horizontal shift, all right, or excuse me, our vertical shift is -9. So here we are. And unlike my graph, we're never going to get below that. So then what we know is that our range would be, once again, an open interval. And it would be -9 to infinity. All right, so there you go. All right, now if I go real quick to number 5, all right, once again, what we know is we know the domain, all right, is all real numbers, and we know that the range, all right, is going to be based off that horizontal asymptote. So it's at 1, all right, so it's going to be 1 to infinity. All right, my friends, and so that's it. So here's what I want you to do. Is I want you to attempt 6, 7, and 8 on your own, all right? And you can check that 1 2 ways. You can turn the video on. I'll kind of run through those very quickly with you and show you how to do those, all right? Or you can just check your answers on the Foley work note sheet and go from there. So whichever way you prefer, do that. But work 6, 7, and 8, check them, and then you're free to move on to the homework. So have a great time. If I don't see you now, all right, I'll see you soon. All right, so for those of you that stuck around, I have taken a picture of the answer key here and added some things in here so that you could see the work here just a little bit quicker than watching me draw everything. But if we look at number 6, we have a horizontal shift to the right 1. We have a vertical shift of down 3. All right, you can see my table here, so those are the points I used. Now notice our a value is 1/2. All right, so we don't really care what the a value is. We're still going to multiply by that value. So notice I would normally go 1 above, all right, my horizontal asymptote from that new origin. But instead of going up 1, I'm only going to go up 1/2. And normally I would go to the right 1 and up 4, but instead of going up 4, I'm only going to go up 2, and there it is. And then once again, just like we talked about before, all right, we know that the domain for all of these, all right, will be just all real numbers, right? So we know that. And then my range for number 6, all right, would be -3 to infinity. All right. Now looking at number 7 here, we can see that we have a horizontal shift to the right 2. All right. We can see that we have a vertical shift of up 2. Okay, and then that a value is 1/4, and which that works out really well because I get some larger values here. So normally I'd go to the left 1 and up 1/5, and I'm only going to go up 1/20th, which is why you can't really see my point there. I normally go up 1, now I'm only going to go up 1/4, and then normally I go to the right 1 and up 5, but now I'm going to go up 5/4, so just above 1 there. And this time I snuck in just another point to help me set my curve. You can always add more points if you want. Don't feel like you have to, but sometimes it just makes it a little bit easier. So I'd go to the right 2, but instead of going up 25, I'd go up 25 fourths, which is a little bit more than 6. So 1, 2, 3, 4, 5, and about 6. And you can see that we have an increasing function this time because our base is greater than 1. Now, we've already talked about it, that we know the domain is all real numbers. So let's look at our range here. And what we know is that range is going to be 2 to infinity. All right, in our last problem here, we have a horizontal shift of to the left 5 and a vertical shift of down 6. All right, so -5, -6 is our new origin. You can see our table here, pace 3. Okay, and then we have an a value of 2. So normally I go to the left one up 1/3. Now I'm going to go to the left one up 2/3. All right, that should be a 1 right there. Let's just change that right now. So 0, 1. And I, instead of going up 1, I go up 2. All right, and then normally I go to the right one and go up 3, but now I'm going to go to the right one up 6. And then there's your 3 points. And then finally, we know that the range, all right, there's kind of an R, all right, would be an open interval from -6 to infinity. All right, my friends, that wraps everything up. All right, so I will see you tomorrow for our next lesson. All right, have some fun. All right, get on. CBS All Access is free for the next month or so. So we're going to try to catch up on Star Trek Discovery, a little Picard action. Yes, we're nerds. You saw the last example in the last lesson about Nerdville. I lived there. Sorry. Take care. We'll see you, my friends.